going to draw one big circle, and for some reason this thing is just going crazy on me. Hold on. Alright, so I'm going to draw a circle. That you cannot see. So what I'm going to do is also trace it in black so it's a whole lot easier to see. Whoops. We won't deal with the stuff down there. Now, in the center of your circle where I have that, I'm going to draw the coordinate plane. And what I'm going to end up doing is I'm going to draw this. And I'm going to call that theta. And we're going to call this degrees and radians. Now, so far, we have been totally concerned with theta. So we've been dealing with theta all by itself, and this is an angle. We know that's an angle, and that's in degrees. On a circle, like what we're dealing with in chapter 3, this is all chapter 3 stuff, by the way, but hopefully you can see how it builds on the idea of the reference angle and knowing the 30-60 or the 30-45 60-degree angles and all of that. Now, when you get your angle and you're dealing with a circle like we're dealing in the unit circle, what happens is you actually cut a chunk of the circle right here. So if it was actually light out, I would this is actually an arc length, and or an arc. You can kind of think of it like that, and we measured an arc length. Now, every degree in a circle cuts a certain measurement out of the circle itself, and the length of this segment from here to here, this is measured in this unit of measurement called a radian. And what the cool thing is that for a certain angle theta, there is a certain radian. There's like a 1-to-1 correspondence. If you have an angle that's 30 degrees, your radian is only going to be a certain amount of that circle. And we can measure it. And we can actually come up with that number. And it's really actually a very simple way to convert. And so we say, how do we convert? How do we convert from degrees to radians or radians to degrees? there are two formulas that you need to remember if this was kind of an old school class, where I would say, all right, do this if theta is this, or do this if you have a certain amount of radians. But what we're going to do is we're just going to come up with one formula that we're going to end up using. And we're going to use that formula, about 100% of the time. Now, what is the measurement of the entire circle in degrees? Alright, so the entire circle in degrees is equal to 360 degrees, right? Now, here's where it gets a little bit tricky. What's the circumference of the unit circle? Because we really care about the unit circle. Well, what's the formula for circumference? 2 pi r. Alright, so if the formula is 2 pi r, what's my r in the unit circle? What's the radius of the unit circle? 1. So it's 2 times pi times 1. So what's 2 times pi times 1? 2 pi. So for the unit circle, 360 degrees corresponds to how many pi's? 2 pi's. And instead of saying that, alright, 100, if we wanted to, we could divide by 2. But this is what I want you to kind of remember, because it relates the circumference to the entire circle. Because sometimes it makes more sense when we're dealing with the whole thing. The circumference to the entire circle, 360 degrees is equal to 2 pi. That's what we'll always end up using. Now, if you divide everything by 2, what's 360 divided by 2? 180 degrees. What's 2 pi divided by 2? 1 pi. We can use both of these to convert, whether it's degrees to radians or radians to degrees. And we always want to keep things in terms of pi. So, before we even get started, 1, keep radians in terms of pi. I can zoom in a little bit on that one. So keep radians in terms of pi, and I apologize for my poor handwriting. It's a huge hurricane of 3 hours of sleep, carpal tunnel syndrome, and just poor handwriting in general. So you're just gonna get, just listen and write fast. Maybe, I don't know. Keep your radians in terms of pi, and always use this. And I would say, use your unit analysis to convert. Eventually, you are going to decide what is easiest for you to convert. What is going to be the easiest way that you can convert things? But unit analysis works 100% of the time. It's very organized. And it works on the premise that you can divide out units. So if you have a unit in the top, in the numerator, that you want to get rid of, we use a conversion factor, which is what these two things are. These are our conversion factors. You can use either one, I don't care. And we can divide it out. Now, here's an example. Convert 30 degrees to radians. Hopefully you start to see a theme of what angles we're going to actually convert to radians to start with. All of them special angles. Now, here's what I would say. We're in degrees, right? We don't want degrees, we want radians. So we're going to start 30 degrees. Now, whatever one you want to use, go ahead and use it. If I want to use 180 degrees equals pi, great. 1 pi is 180 degrees. 2 pi's are 360 degrees. I don't care which one you use. I'm going to use the 1 pi is equal to 180 degrees because they're simpler numbers. But for you, it doesn't matter. I'll show you both ways. Now, degrees go in the bottom here. 180 degrees is equal to 1 pi. Now, the degrees are gone. I'm left with a pi here. How many times does 3 go into 18? 6. So 30 will go into 180 6 times. So I get pi over 6. Now, if I went the other way and said 30 degrees and I said 360 degrees over 2 pi, then you get 2 times 30, which is 60. How many times does 60 go into 360? 6 times. We're left with pi up top. It's going to end up being the same thing. So, pi over 6 is equal, well, I'll say, no, that's not even right. It's equivalent to 30 degrees. Now, here's your task. And your task, this is your task for tomorrow. Okay? But first off, is everybody okay with just this idea of converting from degrees to radians? Now, if we had radians, I should show you that too. I should show you that before I give you your task. Radians to degrees. Same thing. I'm going to say pi over 4. And what I'm going to do is I'm going to go pi divided by 4. Now, the cool thing about this is, since it's a fraction, my railroad tracks end up like this. Since it's a fraction. Which is actually kind of nice. Now, I have the pi up top, so up in the top box are radians. So I want to put my radians down here. So what's my conversion factor? Well, it's 2 pi is equal to how much? 360 degrees. 1 pi is equal to 180 degrees. So, like I said, I don't care which one you use as long as you use one and you use it properly. So, what I'm going to do is, since radians in the top, I want radians down in the bottom. And then, so I'm going to put pi down here. Now what's pi equal to? 180 degrees. Alright, so now you might be able to divide 180 by 4 in your head. Well, think of 4 as two twos. Two twos. Bad joke. Sorry. That's the sleep. That's yeah. Alright. What's half 180? 90. That's one of the twos. What's half of 90? 45. Alright. Pi over 4 is 45. But if you really wanted to, you can build it and say, alright, well, if you're just a calculator junkie and you say, I want to build the unit analysis, it's just ratio after ratio. That's 180 over pi. You get your 45 degrees. But I wonder if we could go from degrees to radians and radians to degrees just like that. Let's check. That's probably number. No, convert, fraction, number tools. No. Whoa, hey. Get back there. No. But I'm going to clear A to Z. Just for fun. Because remember, A to Z are boxes that we can just put numbers in. So, unfortunately, this is not the case. But, here's a hint. Here's a hint for you. A calculator hint. If I'm going to have to do a lot of converting, I might, if I know if I'm going from degrees to radians, or radians to degrees, it looks like I got to multiply by 180 over pi. I might put that in A. Or, better yet, put that in R. Because that'll give me my radians. So, if I do that, and I say, alright, I want to put 180 divided by pi store that in R. Now I can convert. But the problem is if I put like 60 degrees times R, I wouldn't want 60 degrees times R. I'd want like pi divided by 6 times R. And that'll get me to 30 degrees. So you can actually come up with the conversion factor and put it in your calculator, and bam, you get your answers. Or if you want to go degrees to radians, it's the opposite. It's going to be pi over 180. So I might want to put pi over 180, get out of there, and store that in D. But the problem is, if I took 30 degrees times D, I'm going to get this decimal, and that's not going to help me at all. Because when we talk about radians and what we come up with, this is what we want. I want pi over 4. I want things in terms of pi. So converting in the calculator is kind of a bad deal when you're converting to radians, because we want radians in terms of pi, because we like pi. And we want to keep pi out there. So going from radians to degrees is a good calculator problem. That'll get you, your degrees pretty quickly. But going from degrees to radians and making sure that it stays in pi, it ain't going to happen. So you got to know how to do it by hand. All right. Now, here's your task. You will choose to accept it. You are going to create this chart. You'll love it. 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 250, 40, 270, 300, 315, 330, and then 360. So you're going to start with all the special angles that we just dealt with. And here's what you're going to do. You're going to come up with radians in terms of pi. And then I want a sine theta. I want a cosine theta. And I want a tangent of theta. Just the big three. Not the whole thing, but just the big three. And I already know 0 is 0 radians. I already figured out the first two. This would be 30 degrees times 180 over pi, which was pi over 6. And this would be 45 degrees over pi times 180, which is pi over 4. Those are the first three. I know sine starts at 0, and then it goes 1 over 2, then it goes square root of 2 over 2, then square root of 3 over 2, then it goes to 1, and then it goes back down. And I know that guy goes 1, square root of 3 over 2, square root of 2 over 2, 1/2, and 0. So I know this is going to be 0. This is 1 over the square root of 3, so it's square root of 3 over 3. That's 1. That's square root of 3 over 1. That's square root of 3. And that's undeaf. It's like The Walking Dead. It's undeaf. Undefined. Alright. Go forth and conquer for tomorrow.